You know that feeling when you're coding and you think, wait, haven't I solved this exact problem before? Well, you probably have. Today, we're going to talk about a super powerful concept that's all about not reinventing the wheel. We're talking about design patterns, the blueprints for writing really good software.
Look, building software is tough. We all run into the same frustrating roadblocks again and again. But what if I told you that for so many of these common challenges, the best, most elegant solutions have already been figured out? Not just figured out, but documented, tested, and named for all of us to use.
And here's the absolute heart of the challenge, right? The world is always changing, which means our software has to change too. The real magic isn't just building something that works today. It's building something that can grow and adapt tomorrow without having to tear the whole thing down and start over every time there's a new feature request.
So what does this actually mean, inheritance breaks encapsulation? Well, think about it. Encapsulation is all about keeping a class's private stuff, well, private. But with a classic inheritance approach, everything's so tightly connected. You make one little tweak to a parent class, and bam! Suddenly you might have broken dozens of child classes. It creates this massive ripple effect. And trust me, it is an absolute nightmare to maintain.
Okay, so if that old way of doing things is so fragile, how are we supposed to build software that can actually flex and bend? The answer is in these battle-tested blueprints for our code.
And that brings us right to the star of the show, the design pattern. Now, this is crucial. A design pattern isn't a chunk of code you can just copy and paste. No, it's more like a recipe or a game plan. It's a formal way of describing a common problem and laying out a template for a solution that you can then tailor to your own project.
And you know, one of the biggest wins here is that these patterns create a shared language. When one developer on your team says, hey, I think a decorator pattern would be perfect here, everyone else on the team instantly gets it. They know the structure, the intent, the pros, the cons. It just makes your design conversation so much faster and, honestly, so much smarter.
All right, enough theory. Let's make this concrete. We're going to jump into a classic example from the source material, a document editor called Lexi.
So Lexi has this basic text window. Simple enough. But now the product manager wants features. They want a version with a border. Then they want another one with a scroll bar. And of course, they're going to want a window that has both a border and a scroll bar. How do you pull that off without making a huge mess?
Okay, so your first instinct, right? You'd probably just create a new subclass for every single combination. But just think about where that leads. You've got your bordered view, your scrollable view, your bordered scrollable view, and what happens when someone wants a drop shadow? The number of classes literally doubles. You get what's called a class explosion, and it becomes this rigid, unworkable mess. It just doesn't scale.
Thankfully, there is a much more elegant way to handle this. There's a design pattern for this exact problem. It's called the decorator pattern.
And the idea here is just so cool. Instead of locking in all the behaviors when you first write the code, the decorator lets you add new responsibilities to an object on the fly, dynamically, while the program is actually running.
This picture just shows it perfectly. We start with our plain, simple text view. Then, to get a scroll bar, we just wrap it inside a scroll decorator. Want to add a border on top of that? No problem. We just take that whole thing and wrap it again, this time in a border decorator. We're just layering on functionality like Russian nesting dolls.
So how does this magic actually work under the hood? Well, the secret is that the original object and all of its wrappers, the decorators, they all speak the same language. They share a common interface, a common blueprint. That means that to the rest of the application, they all look exactly the same. The decorator just adds its one special feature, like drawing a border, and then passes the rest of the work on to the object that it's wrapping inside. It's so clever.
Here's a simple way to think about it. Imagine the original text view as a plain pizza crust. The crust itself never changes, but you can dynamically add toppings, pepperoni, mushrooms, whatever. Each topping adds its own flavor, its own responsibility, without ever changing the fundamental nature of the crust underneath.
But the decorator is just one tool in the toolbox. A really well-designed piece of software, like our Lexi example, uses a whole suite of patterns, with each one solving a different kind of problem.
For instance, Lexi uses something called the composite pattern to actually build the document. This pattern is what allows it to treat a single letter and a complex paragraph, or even a whole page, in the exact same way. That uniformity is what makes the whole structure so powerful.
And it doesn't stop there. It uses the strategy pattern for things like text formatting. This lets you define a whole family of different formatting algorithms and then just swap them in and out whenever you want. So you could have a really fast, simple line breaker for quick drafts, and then plug in a much more complex, high-quality one for the final print version. The strategy pattern makes them totally interchangeable.
Believe it or not, the full Lexi design uses at least 8 different patterns. They handle everything from creating widgets for different operating systems to implementing undo and redo. All of these patterns work together, in concert, to create a system that's strong, flexible, and way easier to maintain in the long run.
So let's just step back for a second and look at the big picture. Why is it so important for developers to learn this language of patterns? What's the real payoff?
Well, it really comes down to 3 huge benefits. First, you're not reinventing the wheel every time. You're standing on the shoulders of giants, using solutions that have been proven to work. Second, you get that shared vocabulary that just makes your team so much more effective. And maybe most importantly, you start building systems that are designed from day one to handle change, to be ready for whatever the future throws at them.
In the end, design patterns are way more than just about code. They're a way of thinking about problems. They are the invisible architecture that holds up so much of our digital world. And it kind of makes you wonder, doesn't it? What are the recurring problems in your own life that could be solved if you just had the right pattern to follow?